Hi everyone, this is your math guru. In this video, I'm going to show you how to simplify the following radical expressions by using rational exponents. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have a bracket. Find the square root of 49 times y to the power of 2 over m, close bracket, to the power of negative 1 over n. The rule of exponents states that, or the rule of the third rule states that if I have root of a times b is the same as root of a times the root of b. The same applies for your division. So in my first example, I'm going to start with my inner root, which says square root of 49 times y to the power of 2 over m. I'm going to work that out by the side. That's the same as square root of 49 times the root of y to the power of 2 over m. Square root of 49 is 7 times, I'm going to change my square root to rational exponent. Square root to rational exponent is 1 over 2. And applying the laws of exponent, this multiplies each other. I have 2 into 1. I'm left with y to the power of 1 over m. I still have my 7. So replacing that in my question, I have square root of 49 y to the power of 2 over m becoming 7 times y to the power of 1 over m, all raised to the power of minus 1 over n. Also, to change my negative exponent to positive exponent, if I have a to the power of minus x, changing it to a positive exponent is going to be a 1 over a to the power of positive x. So I'm going to do the same. I have this as 1 over, I have my 7 y to the power of 1 over m. Now my exponent is going to be positive, that's 1 over n. Another rule of exponents states that if I have ab all raised to the power of x, the x outside, that's the exponent, is going to multiply all the exponents in the bracket. So that will be a to the power of 1 times x, that's x, b to the power of 1 times x, that's x. So going back to my question, I have this as 1 over 7 to the power of 1 over n times y to the power of 1 over mn. Let's look at the second example. In my second example, I have the cube root of, for my numerator, I have m to the power of 1 over 2 multiplying the root of mn, all divided by 1 over root of n. Applying my radical law and also my exponential laws, if I have the root of m times n is the same as the root of m times the root of n. And if I change that to a rational exponent, it's going to be m to the power of 1 over 2 n to the power of 1 over 2. So applying that, I still have my cube root, that's root to 3. I have for my numerator m 1 over 2. I'm going to change my root of mn to m 1 over 2 and n 1 over 2. Divided by, I'm going to change the n at the bottom to 1 over n 1 over 2. Applying the laws of exponent, if I have the same base multiplying each other, then I'm going to add my powers. That will be half plus half, and that will give us m to the power of 1. And likewise, if I have 1 over n to the power of half, to make it a negative exponent, I'm going to take my base to the top and now my exponent will be negative. So applying those rules, I have root of, I still have my cube root outside. I have m to the power of 1, n to the power of divided by n to the power of negative 1 over 2. And that will give me, applying laws of exponents again, if I'm dividing and I have the same base, I have n half at the top, dividing n minus half at the bottom. The exponent at the top is going to subtract the exponent at the bottom. And remember, or note that the exponent at the bottom is negative. So I have n to the power of negative times negative, that will be positive. So that will give us n to the power of 1. So if I rewrite that, I still have my cube root. I have my m to the power of 1 and n also to the power of 1. And if I rewrite that as a rational exponent, it's going to be m to the power of 1 over 3, n to the power of 1 over 3. I got that from, if I'm changing my cube root of any variable or number, if I rewrite that as a rational exponent, it will be x to the power of 1 over 3, or root to 4 of x. If I rewrite that, that will be x to the power of 1 over 4. Let's look at the last example. In my last example, I have open bracket root to 4 a to the power of 2n minus 1 multiplying root to 4 a to the power of 1, all divided by the root of a. The radical law states that if I have the same root, let's say this is root to y, multiplying, let me say my z, and it's also a root to y, I can merge them under the same root to y. Then I have x times z. So I'm going to do the same for my numerator. I still have my big bracket. I'm going to merge all under my root to 4 a to the power of 2n minus 1 multiplying my a for my numerator, and for my denominator I'm going to change that to a. I'm still going to leave it as my root of a, and the next step I'm going to change that. So for my numerator above, merging the content of my root, I have root to 4, because they have the same base as shown, that's base of a. Then what I'm going to do is to add the exponent. So I have 2n minus 1 plus 1, because there's an invisible one here, divided by, I still have my root of a, close bracket, to the power of 2. That will give us, I still have my b bracket, root to 4 a to the power of 2n minus 1 plus 1, that's 0. I have that as over root of a, all squared. So changing all that to my rational exponent, I have that as a to the power of 2n, all raised to the power of 1 over 4, divided by a to the power of 1 over 2, close bracket, all squared. And I have that as, simplifying, at the top I have a to the power of n over 2 divided by a to the power of 1 over 2. And that will be equal to, applying laws of exponents, I have my squared. A, I can open up with a square, because the laws of exponents states that if I have a over b all raised to the power of x is the same as a to the power of x over b to the power of x. The exponent outside is going to multiply all the exponents inside the bracket. So simplifying further, I have that as, for my numerator, a to the power of n over 2 times 2, that will be n divided by 1 over 2 times 2, that's a to the power of 1. So my final answer will be, applying laws of exponents again, because I'm dividing, I'm going to subtract the power at the top minus the power at the bottom. So my answer is a to the power of n minus 1. Thanks for watching. Bye.